All right, guys, welcome to week 2 of our distance learning. We're going to review from week 1 a little bit here, and I want you to look at initially this slide that I took from a YouTube that I liked, and it just talked about what we did. We did a tree map on this, if you remember from last week. I believe it was even actually a week and a half ago. Let's just talk about data. So what you're talking about this week is you're going to have a bunch of sets of data on your graph, and there are times that it would be going up, as you can see this, where it's a positive slope or a positive correlation is what they're going to call it. Or if it's going down, as the sets of values are going down, decreasing, it's a negative correlation. And then as you see, this is all over the place. There's not a real correlation at all on this idea. You're going to start to see, like I mentioned, the idea of a baby's maybe height or weight would be on this side and the age of the baby. So as the baby's, younger, but as the baby gets older, what do you notice about the height or the weight? It would be getting larger, okay? You're going to be looking at sets of data all the time in your life, and I want you to be able to look at it and kind of make sense of it at times, okay? So this is kind of the warm-up to your notes today, and really your notes today are really going to be maybe some scratch paper that you have in your notebook, and you're kind of keeping an eye on what we're doing. And then I'll probably have a quizzes to follow the notes, and that'll be all of your Tuesday assignment. Wednesday will be an ed puzzle. Thursday will be a quiz. Friday will be a Flipgrid. All right, and I'll explain it all in the Google Classroom. Okay, I took this from your actual one of your workbook questions, and I noticed that I kind of gave you a couple different things to look at on this, and I wanted you to start off a problem just like this. So back in the day, you had no problems looking at something like this, okay? That's a bunch of data, data, and we would say that this would be your X, this would be your Y. So if we drew this table out even differently, you could do a table like this, right? That we're a little more familiar with, which is fine. But either way, you could take this set of data and you could plot it. And that's what they're actually asking you to do. So let's go ahead and do that. If I was to, and now you guys are just paying attention, obviously. You're not writing any notes. In a second, you are going to have to do some work for me. Okay, so you should have some scratch sheet of paper for you. A lot of this stuff, I would give you a handout. We would do it together, but we're in distance learning. It's a little different. I can't be doing that. So let's just do the first set of data, which would be 170. Let me try to be a little more specific. And actually, I'm going to pause it and plot all the data for you in a second here. All right, now let's take a look at this. And this can be a little confusing at first, but the idea is you look at your set of data, and this was all the data from the table. And again, these are all test scores from Ms. Aduki's class. And the one test score was 70%. You see that 70? 2 here would be 75, 3 would be 80 and 85. 4 kids got 85 and 4 kids got 90. Okay, so that's how they're looking at it. Now, if we're going to look at this, I'm going to take my ruler out, and you're going to be like, what's going on here? What you're supposed to do is try to create the best averaged line, and it doesn't always have to go through the points that you think it's going to go through. Like they don't have to be points on the graph. Let me be a little more clear with that. So if I was to put this point right through here, okay, and if I drew that line, let me see if I can draw that line. Let's go a little right here. And I drew, oh, come on, stop. And I drew this line, and I'm going to draw it longer even, just so you can get an idea of what I just did there. I just picked a line that would probably be in the middle of these points. Now, do you see the one point it does go through? It does go through one of these points, which is great. Sometimes I would rather you draw a line that would go through. So if I look at that point, I see that that's actually over 1, up 70, and that was one piece of the data. That was. As I keep going, though, it gets a little more challenging to see what are the other points here on this graph. And what I'm going to do, if I was to look at the 4, so I know this data looks a little different, but if it was here, let me just show you, like right here, that would be over what, 1, 2, 3, 4 kids, and it's right in between 85 and 90. It's actually closer to 90, my line. So I'm going to call it 4 and 88, okay? And that's where this point is right here. Was that an exact point on my data? No, there's no set of data on that, but I'm going to use that point. All right, this stuff is a little intense. Do the best you can. And what you can do now is you have 2 points. And what I taught you last week, and why do you think I went over this last week? You have to now take these 2 points and now go ahead and create an equation from those 2 points. Now, how do you do that? Do you go y minus y, right? So what would you do? 70 minus 88. Do you see that? Y minus y over x minus x. All right, and if you need to use your calculator, go for it. Why don't you take a second, push pause, and try to solve that. As I do this, I get negative 18 over negative 2. All right, and negative 18 over negative 2, I know 2 goes into 18 9 times, and 2 negatives equals a positive. So guess what I have just figured out? I have just figured out that that is the part of my equation, 9x, okay? Interesting. Now, what would I do? Would I plug in maybe a point? Could I plug in this point? Where would the 1 go? Where the x is? Where would the 70 go? Where the y is? We did this last week. If you need a refresher, go see the notes from last week. Now 70 equals 9. Well, obviously 70 doesn't equal 9. What would I have to add to 9 for 70 to equal 70? That's what we want. And if you see it, eventually you're going to notice that it's actually going to be, 61? So then I go ahead and make this equation right here, okay? And as I put in my x values of the numbers of students, I'm going to get the score. So this is kind of confusing to think of with this exact word problem, but it's almost right. I mean, the 61 could be right there. I know the line doesn't look exactly perfect, but that is the actual equation of the line. So the equation of the line would be y equals 9x plus 61 with my data. All right, I know it looks weird on the screen because I just deleted it all, but hopefully you could see that that's where it happened right there. So the biggest part was to draw your line of best fit. And that's also what I want you to remember. This is called a trend line. And sometimes they also call it a line of best fit. And this stuff is not easy, so you're gonna have to take your time looking at what's going on. All right. This is the last new curriculum I think I'm going to teach you, and a lot of this stuff is old. Everything we did over here was old first semester stuff. All right. That's why I like using them, doing this stuff. All right. Let's do another one. All right. Take a look at the one I just gave you here. Now this one is a little bit of a cleaner way of doing it. I'm still going to use the ruler, but do you notice that they gave us 2 points? And I think that's interesting. There must be a reason for that. I think they want us to use those 2 points to create our equation. So really, all this became was a unit 1 kind of question. I'm still